are using them for devices. Okay, this is the contents of my talk, right? There are 5 of them. First of all, I will introduce, or maybe you already know what is nano and nanotechnology, right? Okay, anyone doesn't know what is nano? So I used to talk to a high school student, okay? So I have to use the word nano means 1 billion, 1 part of 1 million, 1 billion, okay? But for university students, I will simply say 10 to the power minus 9. You should understand what is nano, right? Okay. Just to give you some example here, right? The height of a child is 1 meter. Maybe your brother at this height, 1 meter. Okay? And this is 1 billion nanometer. So if your brother this tall, right? If you shrink it 10 times, 1 meter is this long, right? Shrink it 10 times. 10 times again. 10 times again. If you repeat 9 times, 10 times, and 10 times again, then you get 1 nano. Okay? And the diameter of your hair, most of your hair is 50,000 nanometer. Huge! Right? This is 50 micrometers, which is 50,000 nanometer. Right? The red blood cells is a few thousand nanometer, shown here. Right? So DNA, you know what is DNA, right? DNA is double helix structures, looks like this, right? And the width itself is about 10 nanometer. And have you ever heard of a hydrogen atom? Hydrogen atom is the smallest atom, right? So if you catch hydrogen atom, 10 pieces of them, you line them up in a row, 10 pieces of hydrogen atoms will give you 1 nanometer. So did I give you the idea how small is 1 nanometer now? Okay? Okay, nanotechnology. Alright? This is my definition. Okay? Nanotech is the understanding and control of metal materials, right? In the dimension 1 to 100 nanometers. Okay? Not only just make it small, but they have to have unique properties that enable new applications that cannot be done by conventional technology. Okay? And it involves imaging, measuring, modeling theory, or manipulate. Manipulate means you will be able to catch one piece of nanomaterials, turn them left, right, put them up, down, or whatever, as you wish. That's manipulating. Okay? All these are nanotech, including growth, characterize, manipulate of nanotubes, nanowire, nanoparticle, or fabricate them for devices. Okay? And the key thing here is that, I didn't put up a slide, is the so-called bottom-up approach. And the opposite will be top-down approach. Right? Top-down approach means, for example, silicon. You have silicon wafer, silicon crystal, baked crystal, right? You slice the silicon crystal to pieces of dish. You polish them, clean them, you form the wafer, right? And the wafer, you use the so-called lithography technique to make them in microstructures. So from a big chunk, you take all of them away and let the small one for your IC chip. That is called top-down approach. So you have been wasting a lot of materials. Nanotechnology is supposed to be opposite, which is the bottom-up approach. Bottom-up means from the small. Okay? You catch one atom, put them here. You catch another atom, put them here. You line the atom nicely to the way that you want in a controlled way, so that they behave in the way that you want. So this is the true nanotechnology. Okay? So can you differentiate what is top-down and bottom-up now? Okay? So this is bottom-up nanotech. A lot of people claim that they work on nanotech. Actually, they're still using the top-down approach. Right? Now, speculation. Right? And actually, when this was promoted in the United States in the year 2000 under the National Nanotechnology Initiative, if you go to nano.gov, right, you can see more details about this one. Now, the prediction is that 6 years from now, right, half of the new product in advanced industry area, including materials, electronic, drugs, chemical, right, etc., right, will involve nanotechnology, which means this is about 6 years later. Most of the new product that come out, they might be using some kind of nanotechnology inside. And now say even if you go to supermarket, you see a lot of names called nano. I'm not sure how nano they are actually. But anyway, let them call it nano. Anyway, not only that, $1 trillion world market of product, right? Is a key component based on nanotech. And 2 million jobs worldwide, new jobs will be created. These are the so-called predictions, right? And actually the US has been investing more than $1 billion in research a year. And not only just US, European, Asian countries including China, Hong Kong, right? They invest a lot. It sounds skeptical, right? When you talk to people, talk big in front of other people say, can I trust you? Right? So let's give you some example here. In 1990s, about 100 years ago, right? Every 4 person that you meet, one of them will be a farmer. Right? And at that time, if you tell them, hey, don't be farmer, do something else. Because 100 years later, only less than one of us in 100 of us will be a farmer. No one will do agriculture anymore. Do you think 100 years ago people will believe you? It sounds skeptical. What can we do? That's all we have, land, water. We can only do farming, other than that we do nothing. That was skeptical. But actually it comes true, right? and now, 100 years ago, most people will die in the early 40s, 40 years old or 50 years old, in average 47. And then you tell them, be patient. 100 years later, you will be 70 years old. People will be 70 years old, won't die so soon. Do you think they will believe you 100 years ago? It sounds skeptical, but it's happened now today, right? Okay. This one you can read, okay? About 100 years ago, the president of Royal Society in Great Britain, they said, anything heavier than air cannot fly. Now say how many flying out from Malaysia to Langkawi? Or to anywhere else. They're very heavy, right? In 1943, IBM, the chairman, at that time, how big is a computer? You fill up the whole building, the whole floor of the building, one computer. Right? So this president of IBM said, there is a world market of computer of just 5. We can only sell 5 computers to the whole world. Now instead, do you have more than 5 computers in MMU? It's even more than that. Alright, things always sound skeptical. They are more, okay? But we can keep ourselves skeptical, but we have to look into the details and see what will be the promises, what will be the challenges for us to solve. Can we make this come true? Okay? This is how the civilization of mankind. Okay? Now I'm going to give you the example of the so-called carbon nanotubes here, right? To give you some idea about nanotechnology. Diamond, right? All these materials are based on carbon. This is diamond, right? They are made of carbon atoms. And all these carbon atoms, for example here, they bonded to 1, 2, 3, 4 in a tetragonal structures. They have 4 good friends. Okay? Every atom has 4 good friends. So it looks the same in every direction, and they're very strong. That's what they call diamond. And they are insulating, transparent, right? And now, if you move down here, the so-called graphite, they also constructed by carbon. But each carbon atom is now connected to 1, 2, 3, only 3 neighborhoods. And they form the hexagonal sheet structures. Every sheet we call graphene sheet. And this is what you have in your pencil.